I'm Aditi, and today we are going to begin foundation course for the subject chemistry. So, am I audible to everyone? Okay. Is my screen visible? Okay, so we will begin now. First and foremost, before jumping into the topics, we must know what is chemistry. So, everyone knows that chemistry is a part of a science. It is a subject in science. So, can someone tell me what is chemistry? Well, okay, chemistry is a study of matter. In matter, we study what do we study in matter? We study property, we study interaction, behavior, the way matter reacts and combine and form variety of substances. So chemistry is a part of natural science. Just a second. Yeah, I'm sorry. Okay. So within chemistry, there are many branches. Chemistry is divided into variety of branches. Major, we know four of them. It is organic, inorganic, analytical, and physical. Apart from that, we have environmental chemistry, quantum chemistry, polymer chemistry, and so on. Uh, so today we are only going to study basic chemistry of standard 6. So, in the textbook of Standard 6 NCRT, following are the topics which belong to the subject chemistry. The first one, the component of food. This particular topic. It can be classified within biology as well and in chemistry as well. The second topic, sorting materials into group. This particular topic discuss about classification of material into variety of group. It is a very simple chapter. The third one, separation of substance. In separation of substance, we will learn method of separating a mixture. There are variety of methods which we will be discussing in this chapter. Fourth one, changes around us. Changes around us discuss about the changes, physical and chemical changes that occurs in our surrounding. The last two chapters, water and air. Now, these are the topic of environmental chemistry. Within this, we will study the property of water, uh, the water cycle, how water is conserved, water pollution, air pollution, components of air, and so on. Um, yeah, okay, I'm sorry for the interruption. We will continue. In seventh NCRT, we will study three topics within chemistry. First one is heat, second is acid, bases, and salt, and third is physical and chemical changes. Now, physical and chemical changes here, it is a continuation of the previous chapter changes around us. In it, these are the topic. In the ninth standard NCRT, the following are the topic, and these are the topic in 10th. We will start from the sixth standard because it is the basic. It includes very basic topics, and we will quickly finish all of those topics. So sorting materials according to group. Now, in this topic, in this chapter, we will study about classification of material, how materials are classified. Before studying classification, we need to understand what is material. So what is material? Material is a physical substance. It can be any physical substance around us, anywhere. So the examples of material are plastic, ceramic, glass, fiber, etc. These are some categories of material. So the object we are surrounded with, they are made up of material. Okay, they are made up of variety of material. They can be made up of one single material, or they can be made up of multiple material combined together. So first, moving on to the classification, the basis of classification. So on what basis we are going to classify these materials? This will be a very simple classification, and it will be based on similarities and differences. So similarity and differences of the properties of the material. On that basis, we will classify our following materials. Somebody raised their hand. Yes, you can ask in chat box. Whatever questions you have, you can ask in chat box. I will reply to them later. So moving on, as I was saying, materials are classified on the basis of similarities and differences in their properties. So what properties are we going to consider? We are going to consider simple properties like appearance, hardness, solubility, and transparency. We will be discussing each one of them separately. Okay. So before discussing them, we need to answer the question of why are we classifying the materials? What is the need of classifying the materials? So we classify materials simply for our convenience. Now, first property, appearance. The materials that have luster. Luster is shine. So the materials that possess the property of luster are usually metals. Now, focus on the word usually. Not everything that shines will be classified as metal. For example, iodine. Iodine in solid state has luster. It shines very brightly. But iodine is not a metal. It is a non-metal. And diamond also possesses luster. And but diamond is not a metal. Diamond is a non-metal, which is why we say that the materials that possess luster usually are metals. Okay, so the examples are given below: iron, copper, aluminum, gold, silver. Now, these are the metals that we use daily, uh, and the names in the bracket are the symbol of the element. We will be studying the symbol of the element in the later chapters. I just mentioned them here. So materials like paper, wood, plastic, rubber, these are the materials that do not possess any luster. Okay, so the metals which we use daily, like copper, like some silver jewelry, these are the materials that lose their luster over a period of time and they become dull. Now, why does this happen? This happens because the surface of the metal comes in contact with air and water. And once the metal surface comes in contact with air and water, it reacts and forms a thin film over the metal surface, which hides the luster of the metal. So that was all about appearance. The next property is hardness. So material can be classified as hard or soft. So the materials which can be compressed, which can easily change their shape under pressure, are called soft. For example, cotton or sponge. While the materials which are difficult to compress are hard. For example, iron. Iron is hard. This was a small point. Moving on, the next point is solubility. Now, solubility, material can be soluble or insoluble. So a material, if a material dissolves in water, then it will be soluble, and if it does not dissolve, if it floats or it is suspended in the water, then it is insoluble. Okay. So before moving on, you need to understand one term: solution. So what is solution? Solution is basically solute plus solvent. Solution is made up of solute and solvent. Solvent is usually the material in which solvent is usually the material in which the solute dissolves, and solute is the one which is getting dissolved. Okay. So the substances which do not mix with water and do not disappear after we stir for a long time, these are the substances which are insoluble in water. They will lie suspended in water or they will float on the surface of the water. Okay, so solubility of some solids in water. We are going to take a few examples of solid and we will see if they are soluble or not. So salt is soluble in water, sugar is soluble in water. When we mix salt or sugar in water, they form a uniform solution with water. However, sand will not be soluble in water. It will settle down at the bottom of the vessel. Same goes with chalk powder. So they are both insoluble. Now, uh, now we'll study about solubility of liquid in water. Earlier we talked about solubility of solids in water. But when we speak about two liquids being soluble in each other, we use the word miscible and immiscible instead of soluble and insoluble. So when we have two liquids and they combine with each other, mix with each other to form a uniform solution, we call them miscible. And when two liquids, they do not combine with each other and instead they form layers. They are called as immiscible liquids. So some examples of liquid: lemon juice is miscible with water, vinegar is miscible with water. However, kerosene and coconut oil or any type of oil, it will not be miscible with water. It will form a layer above water. So it will be immiscible. Okay, moving on, we discussed solubility of solids and solubility of liquid in water. Now we will discuss the solubility of gases in water. Usually gases are not soluble in solvent, not soluble to a very great extent. Uh, they are soluble for a very small extent. So there are few gases which are soluble in water. For example, oxygen, carbon dioxide. Oxygen in the natural water bodies like pond, river, you will find dissolved oxygen within water. It is already present there. It is because of the underwater plants which are present in the surface of in the bed of the water body. Uh, okay, so this dissolved oxygen in the natural water body, it helps for the survival of the aquatic life within the water. Speaking of carbon dioxide is dissolved in water and it gives us soda. The soda drinks that we have, the carbonated drinks. In the carbonated drinks like Pepsi or Limca, uh, we dissolve carbon dioxide in water. So that those small bubbles we see in the bottle are the bubbles of carbon dioxide trying to escape. Now that was all about solubility. Moving on, the last property, it is transparency. Now transparency, the substance or material through which we can clearly see through them. They are transparent. For example, glass, water, some plastic, they are all example of transparent materials. However, on the other hand, there are materials uh, through which we cannot see. For example, a cardboard box or a metal sheet. These are the things we cannot see through. So they are opaque. There is also a third category which is known as translucent material. Now, materials through which we can see, but we cannot see clearly. Now, these are the things which are translucent. For example, a oily patch on the paper. We can say that we can see through oily patch on the paper, but we cannot see very clearly. It, it won't be classified as transparent, but it will be translucent. So therefore, on the basis of transparency, we can group the materials as transparent, opaque, or translucent. Now there is a question: when we cover the palm of our hand with a torch in a dark room and we switch on the torch, so the palm of our hand will be classified as which of the following? Will it be opaque, transparent, or translucent? Can any one of you answer? Okay. So Yash has said opaque. Why not translucent? Because when a strong beam of light is passed through our palm, we can see the red color vein and all of those things. Okay. So most of you all are saying opaque. Okay, fine. You are right. It is opaque. Okay. So that was all about sorting the materials into groups. We've successfully classified all the materials in depending upon their properties. Now moving on, separation of substances. Now in this topic, we will be discussing simple methods of separation of substances. Some examples of separation of mixtures that we see in our daily life. For example, tea leaves are separated from tea using a strainer. Grains are separated from stalk while harvesting. Milk is churned uh, to separate the butter. Okay, so what is the need of separating substance at all? So there are 3 points in this. We separate two different but useful components. In this, when we separate two components, both are useful to us. For example, a handful of rice and pulses mixed together. Now, both of these components are useful. Secondly, to remove non-useful component. Example for this will be rice with small pebbles or stones. Now, stones are non-useful component and we need to remove it. And thirdly, to remove impurities. Now, to remove dissolved impurities from water, because we cannot drink impure water, it will be harmful for our health. So, these are the 3 reasons we need to separate the substances. There is a need for method of separation. So, method of separation, the first one is hand picking. This is the most simplest method. This method can be used for separating two components which differ from each other in their particle size. For example, pieces of dirt, stone, husk from wheat, rice, or pulses. The quantity of impurities are usually less, they are not very large. In such situations, hand picking is convenient. Second one is threshing. Now, threshing, this particular method is used mostly in farming and agriculture. It is a process that is used to separate grain from stalk. In this process, stalks are beaten and the grains, due to the force, they are freed and they fall on the floor. So threshing is done with the help of bullocks. When there is large quantity of stalks, machines are used in such cases. So even after threshing, some of the stalks are present in grain. Now these stalks, which are now known as husk, mixed with the grain, these are kind of impurities, non-required substances mixed in the useful component. So in order to separate that, we will use the process of winnowing. Now winnowing is used to separate heavier and lighter component of a mixture by wind or by blowing air. As it is described in the image, you can see As the seeds and the grains are poured in the floor, the husk will flow away in the direction of the wind, and we will separate the two components. Now, sieving. Sometimes, even after threshing, winnowing, and doing all of those separation method, there are still certain impurities and certain components that we need to remove. For example, small pebbles, small stone, husk, sometimes stalk. Now, these can be removed by sieving. Okay, so those were the four methods. They were main. Those four methods are mainly used in agricultural sector, farming, and all of those. Now, moving on, sedimentation, decantation, filtration. Now, when the heavier component in the mixture settles after water is added to it, the process is called as sedimentation. In other words, when we add sand to water and sand gets settled in the bottom of the vessel, that will be sedimentation. In sedimentation, a layer of sediment is formed at the bottom of the vessel. Now, after sedimentation, the water which is left above, usually mixed along with dust, which are dissolved in water. So they do not get sedimentated and they are in solution with water. Now, this water, along with dust, it is removed, and this process is called as decantation. This removal is done very carefully so that the sediment which is formed in the bottom of the vessel, it does not get disturbed. Now, this same principle of sedimentation and decantation is used for separating mixture of two liquids. Now, mixture of two liquids that do not mix with each other. For example, oil and water. If we take oil and water and we mix them, after some time, oil will form a separate layer above water. And then we can use the process of decantation and remove oil from the water. Now, in the previous example, we separated water from sand, but now water has some dust and soil particles still dissolved in it. That can be removed by the process of filtration. We can simply pour water through strainer, but usually strainer has large pore size, so it does not filter out the dust particle or soil particle in the water. So instead of strainer, most of the time a thin piece of cloth is used to strain water. However, in chemical lab, we use filter paper to perform the process of filtration. To remove the impurities, we use filter paper. Filter paper comes in wide variety. They are classified on the basis of numbers. For example, like Wattman filter paper 41, 42, they have numbers, and these numbers, they are based on the pore size of the filter paper. Okay, so the next method of separation is evaporation. Now, evaporation is simply conversion of water into vapor. Conversion of liquid water into gaseous state is called as evaporation. Now, how does evaporation help in separating? So, when seawater uh, in the areas, in the coastal areas, the seawater, I'm talking about the salt plain, how the salt plain works. So for salt plain, we dig shallow pits near the beach, and seawater is poured in such pits and left there and it is left for a few days so that the water is evaporated. Seawater contains water along with mixture of variety of salts. Now, once the water is evaporated, this mixture of salts is what we have behind. Then this mixture of salt is further purified to get common salt. Common salt is what we use for cooking. Okay. So now use of more than one method of separation. Sometimes using just one method of separation will not give us, uh, will not separate our mixture. For example, if we take the mixture of sand and salt, now In order to separate sand and salt, first we will have to dissolve the sand and salt mixture into the water. What will happen? The salt and water will dissolve and form a solution, but sand, it will form a sediment at the bottom of the vessel. So we can separate sand by sedimentation and decantation. Once we decant the salt water solution, sand will be separated. Now coming to the salt water, how do we separate salt from water? So for that, we will use a new method called condensation. So in condensation, what happens? It is like exact opposite of evaporation. In condensation, the water vapor is converted back into liquid. So in order to separate salt from water, we follow a simple procedure called as simple distillation. In simple distillation, what we do, we have a flask in which we pour water along with impurities. It could be anything. It could be dissolved salt or any other compound. And once water along with its impurity is poured into this flask, it is heated. The flask is heated. At 100 degrees Celsius, the liquid water converts into vapor. And this vapor travels through the narrow neck of the flask and moves into a machine which is called as condenser. Now, condenser has a surface which is very cold. It is cool. Once this vapor passes through condenser, the condenser, what it does, the vapor comes in contact with the surface of the condenser. The vapor cools down and converts back into liquid. And this liquid is collected in another vessel. Now, the liquid that we get by condensation, by performing distillation, it is called as distilled water. Distilled water is free of any impurities, it is free of salt, and it can be used for drinking. Okay. Yeah. So moving on to saturated solution. Now, what are saturated solution? As I told you, solutions are solute plus solvent. So many substances, they dissolve in water and form a solution. For example, if we take a glass of water and we dissolve a spoonful of salt, the salt will dissolve in a minute or two. It will completely dissolve in water. But what will happen if we keep on adding salt? Uh, if we keep on adding spoonfuls of salt at after a few intervals, we will reach a point at which no more salt can be dissolved in water. So this is what we call saturation point. A saturated solution is a solution in which there is so much solute that if any more amount of solute were to be added, it would not dissolve. So once once you add salt in water and continue adding it, you will reach a point where no more salt will dissolve in water, and the salt will start to collect in the bottom of the vessel. At that point, you can call your solution saturated. Now, is there some way that water could be made to dissolve more salt before the solution gets saturated? Now, I want to dissolve more amount of salt in the same amount of water beyond the saturation point. So, is there a way I can do that? So, yes, there is a way. What I need to do is I need to heat the vessel in which my saturated solution is present. Once the temperature is elevated, the undissolved salt will start to dissolve. So at higher temperature, the saturated solution is capable of dissolving more amount of solute. Okay, but once we cool down the solution, the dissolved solute will become undissolved once more. Okay, so does the water dissolve equal amount of different soluble substance? Now, what if we take 2 glasses of water and we start adding salt in one and sugar in another? Will the amount of salt be equal to the amount of sugar to reach saturation point? So no, it will not be equal. The nature of solute decides the amount of solute required to reach the saturation point. Yeah, so that's it. This chapter ends here. So today we covered two topics, sorting of material into groups and separation of substances. Both of these topics were taken from 6th standard NCERT. If you have any questions, you can ask, or if you want to add something extra, you can also add that. The level of difficulty will go on increasing as we progress. This was a very simple topic. Digiraj Thakur, I don't know what you're asking. I can't understand. Saturated balance. सैचुरेटेड का मतलब बैलेंस नहीं होता है. सैचुरेटेड का मतलब होता है एक पॉइंट सॉल्यूशन का जिसमें और सॉल्यूट ऐड नहीं हो सकता. दैट इज सैचुरेटेड. इज इट क्लियर नाउ? Okay. Anyone want to add anything? Okay. So I will conclude my lecture now. Next time we will be studying structure of atom because that is like the beginning of everything. We can start with acid or base or acid and base or metal or non-metal, but for that we will need a little basic. For example, you will need to know what a compound is, what a molecule is, what elements are. Once you know that, we can proceed with all the other chapters like metal and non-metal, acid and base. Okay, yes sir. Yes sir.
एक मिनट मेरे को जाने का तो बना दीजिए. हाँ. हेलो हेलो, मेरी आवाज आ रही है?
यस सर.
या ये सारी क्लास 6 की जो आपने एनसीईआरटी देखा, काफी चीज इश्यूज हो गई हैं. मैं ये कहता हूं आप लोग पिछले सालों के क्वेश्चन पेपर देखिए, सवाल ऐसे ही आते हैं. हम लोग लगातार फेल सिर्फ इसलिए हो रहे हैं अपने को पता ही नहीं आता क्या है. हम लोग जबरदस्ती कुंजियां पढ़ते हैं, कहते हैं मार्केट की किताबें पढ़ते हैं. कोई जरूरत नहीं है. आप पहले एनसीईआरटी पढ़िए, आप जरा निकाल दिए, सवाल ऐसे ही आते हैं. हम लोग लगातार कोशिश कर रहे हैं, आप लोग सही रास्ते पर। एक तो क्या है कि पढ़ने वालों की तादाद बहुत ज्यादा है नहीं मेरे पास। आज फिर क्या 42 लोगों ने ज्वाइन किया, 200 लोग इनरोल हो जाते हो, ज्वाइन किया आपने 42 लोगों ने। ठीक है, जो भी लोग ज्वाइन करते, जो लोगों को नहीं पढ़ना आप लोग वेंचर छोड़ दो, हमको वेंचर चलाने दो उन्हीं लोगों को जो लोग यहाँ पे पढ़ना चाहते हैं। दूसरा, जो लोग भी पढ़ रहे हैं, आप लोग एनसीईआरटी ऐसे ही देखने की कोशिश करो। जो भी टीचर आते हैं बड़ी मेहनत से चार्ट बनाते हैं, आप उनको ध्यान से सुनो, आप उनके सवालों का जवाब दो। अब आप जाके एनसीईआरटी पढ़ो। जो अदिति ने क्लास लिया है, उस क्लास में उसने एक नया दृष्टिकोण दिया है, आप इस दृष्टिकोण से क्लास को देखने की कोशिश करो। थैंक यू, टेक केयर। बहुत अच्छा किया अदिति आपने। आई एम वेरी हैप्पी टू सी योर लेक्चर। थैंक्स लॉट,
Thank you,
थैंक्स
sir.
लॉट।